All right, so let's pick up where we left off in the previous video. So in the last video, we went through and found the equilibrium point of the XY system, and that was 3, 2. Then we went in and did a change of coordinates to change the X and Y coordinates into UV coordinates. And in doing so, that made the origin our new equilibrium point. So now we can go in and find eigenvalues and classify it. So again, we're going to be looking at the system in UV coordinates right here. And so that matrix A is going to be -4 and 2 and 1 and -2. And just like we always do, we're going to subtract lambda off of the main diagonal and set that determinant equal to 0. So we're going to have a -4 minus lambda times our -2 minus lambda minus 2 is equal to 0. So 8 plus 4 lambda plus 2 lambda plus lambda squared minus 2 equals 0. So lambda squared plus 6 lambda plus 6 is equal to 0 is our equation. Now you'll notice that we cannot factor this, so we're going to complete the square on it. So we're going to have lambda squared plus 6 lambda. And then we're going to add 9 to both sides. So that left side is going to factor as lambda plus 3 squared, and we get a positive 3 on the right-hand side. Now, if we take square roots of both sides, we're going to end up with lambda plus 3 equals plus or minus square root 3. So lambda is equal to -3 plus or minus the square root of 3. And if we think about that, lambda 1 is equal to -3 plus the square root of 3, and lambda 2 is equal to -3 minus the square root of 3. Both of these eigenvalues are negative because, of course, 3 is bigger than the square root of 3, and they're real numbers, so we know that we are going to have a sink node at the point 3, 2. And to think about this visually, the idea is that we have ourselves our normal XY coordinates, but our new equilibrium point is actually at 3, 2, so it's over here. And once again, there's 2 eigenvalues or eigenvectors going through it, and we're going to have flow towards the equilibrium point because we have the negative real parts are just negative eigenvalues. So again, that is a little sketch of what the phase plane looks like in XY coordinates. And of course, you could go to the p-plane program and verify this as well.